Welcome to HP Tuner's GM Gen 5 training part 37. In this training module, we're going to be exploring the speed density operation, learning how it works, and learning how it integrates to the virtual volumetric efficiency. We're going to take a look at that entire process, making sure that we can understand how this airflow model is going to be working in the background for the Gen 5 vehicles. We're going to have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our speed density operation in our GM Gen 5 vehicles. This tutorial, we're going to be looking at the basics and fundamentals of speed density operation. We're not going to look at the calibration process yet. That's coming up in the next few training modules. Now, we're going to be focusing here on where we can find the speed density tables, how speed density is calculated, how we have a tool called the Virtual Volumetric Efficiency Calculator, how it's going to play a role in our speed density air mass calculation. And then finally, we're going to take a look at some log data in our VCM scanner to break down and understand the concepts that we talked about here in the tutorial a little bit further. So the first thing I want to do here is take a look at any Gen 5 file. In this case, I'm looking at a 2018 Yukon Denali. I'm going to go and locate where we can find our speed density tables. And then we can start to break this down of how this is all going to work. So the file I have open here is from our test vehicle, 2018 Yukon Denali. I'm going to go up here into my engine tab and go from general here into airflow. And then from airflow here, we can move from our general tab over into our speed density tab right here. Now under speed density, we have our area here called VE coefficients. This is going to be where we actually can get a value called our volumetric efficiency, or the percentage of cylinder filling, to fit into our speed density equation. Now, the speed density air mass or airflow is going to be a calculated amount. It's something that we are going to be using to compare against the mass airflow registration of airflow coming from our sensor's measurement. This is going to be a checksum against that at any given time. We'll find that we have a parameter called here dynamic that's going to be looking at and comparing both the mass airflow and speed density calculations, and it has the ability to use one or the other or have a weighting factor between these two to determine what the final air mass is going to be that it uses for fuel, spark, and torque calculations. So it's imperative that we get our speed density calibrated right, and we'll find that we're going to be working essentially within these VE coefficients to make sure that that is going to happen. This is what we are basically interfacing with and tuning and dialing in to make sure that we're representing that percentage of cylinder filling based on the modifications that we have done. If you've installed a camshaft, if you went force induction, even if you've done basic bolt-ons on your Gen 5, chances are you've disrupted the original calibration for the volumetric efficiency from GM, and we have to jump back in here and dial it in, especially with a cam or force induction. It's an absolute necessity. Even with bolt-ons, I recommend you at least go through and check everything. It's going to be close, but you probably can get a little bit closer and make sure that it's on point. What we want to find is that at any given operation point, whether we're measuring the amount of air mass coming from our mass airflow sensor or calculating the amount of airflow or air mass at that exact same moment, we should find that they line up together. That should make sense. There shouldn't be a deviation. Whether we're calculating or we're measuring it, they should be identical to each other, because air entering the engine is air entering the engine. So we'll find the way that the vehicle is going to be running, and all of the calculations that are performed in the background hinge upon having the airflow models matching each other. So our goal here is to make sure that our speed density is calibrated properly. So what we're going to do right now is talk about how it's actually calculating what the air mass is going to be. It's pretty straightforward in terms of the equation here. Let's take a look. We'll find that the speed density air mass, or what's known as the volumetric efficiency air mass, is going to be the volume per cylinder multiplied by the map pressure sensor reading, which is a sensor that's measuring our vacuum or pressure on our intake manifold, divided by a gas constant, universal gas constant, which is 287, multiplied by our intake air temperature in units of Kelvin. The intake air temp is going to represent the density of the air. So we have both the volume and the density. We know that's going to be needed in order to figure out air mass. Once we have that, fit that into the equation here, then we can calculate a total air mass. Now we also have, finally to that equation, multiplied by a percentage of VE, or cylinder filling. And that's where our VE coefficients here come into play to determine what that value is going to be. So at idle and part throttle, we have a lower volumetric efficiency. We have lower airflow being packed.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.